With the probability of independent and dependent events, you have to think a little more. You have to ask yourself questions like, does the action of the first event affect what's going to happen for the second event? An independent event, this is where the occurrence of one event does not affect the probability of a second event. If I were to flip one coin, what it lands for the first coin does not affect what happens for the second coin. Or drawing a card from a deck, I'm going to draw one out, and if I return it and draw a second time, the probability is not affected. Both times I'm drawing out of 52 cards. I'm going to contrast that with dependent events. This is where the occurrence of one effect does affect the probability of a second event. You'll want to underline that word does. It does affect the probability of a second event. So, the chances of me drawing a 4 of hearts is 1 out of 52. Okay, so for the second card, it's going to be 1 out of 51. I still have it in there. There's still a 4 of hearts somewhere in here, but since I've drawn this card out, I have 51 cards in this deck now, so the probability of the second event of drawing 5 of hearts is a 1 out of 51 chance. So the first skill is determining if events are independent or dependent. So the first situation, Erica rolls a 3 on one number cube and a 2 on a number cube. These are independent events. What Erica rolled on the first number cube has absolutely no effect on the second number cube. When she rolled a 3, that did not say that she could not roll another 3. So let's look at the next situation. Tommy chooses a 7th grader for a team, and then Jack chooses a different 7th grader. So think about when you're in PE and you're selecting teams. When that first team captain selects, he has out of, let's say, 24 students to choose from. But when the second team captain goes to pick a person for his team, he has 23 to choose from, and then it goes back and there's 22 to choose from, and then 21. With each event, the number of possible outcomes goes down by 1 because Tommy is not going to pick someone from his team and then return that person back. He's not going to do that. He selected that person, and so now the second event has been affected. So the second one is dependent. You're going to know it's dependent because whatever it is that you're selecting or that event, it rules out that event is happening again. Tommy cannot choose, Betty, and Jack can't choose Betty as well. There has to be, once Betty's selected, then that's not a choice for Jack. Or in a deck of cards, once I pull that card out, I can't choose it again because it's no longer in the deck. So here's how you find the probability of these different kinds of events. If it's an independent event, meaning that the probability of A, the first event, does not affect B. To find the probability of A and B, the probability of rolling a 2 and then rolling a 3 is equal to the probability of the first event times the probability of the second event. Whereas the probability for dependent events, it's different. You're still multiplying, but that second thing that you're multiplying is still probability of the first event, but it's the probability of the second event given the first event has occurred. So if we are wanting to draw a diamond and then a 4 of hearts. So if I wanted to draw probability of a diamond, then a 4 of hearts. The probability of a diamond is 1 out of 4 because there are 4 suits. 1 out of every 4 in here. So I'm going to select a card out of there. Now for the second time, the 4 of hearts. There is one card that's a 4 of hearts, but that's out of 51 cards now. So when I multiply across, that's a 1 out of 204 chance that I'm going to draw a diamond and then a 4 of hearts. So let's practice this a little bit. To find the probability of each set of events, so rolling an even number on a number cube and rolling an odd number on a second roll. These are independent events, so I'm not having to think about odd after rolling an even. They're independent, so I just multiply the probability of each of those. Even numbers are 2, 4, and 6, and there's 6 possible outcomes, so that is 3 out of 6, or 1/2. The probability of rolling an odd, this is the complement, or you could think of it as 1, 3, and 5, which is also 3 out of 6, 1/2. I multiply those two together, and 1/4 is the probability of that happening. Here's some for you to practice on your own. Go ahead and try that and then compare with what I do. So for practice A, the probability of drawing a red and a blue. So probability of the red is 6 out of 10 because there are 6 out of 10. I got 10 from 6 plus 4. Times the probability of the second thing happening. It said that I replaced that marble, so I'm back to 10 marbles in there. Times 4 over 10. You get 24 over 100, which reduces to 6 over 25. Situation B. It's the same thing, but what's the probability if you did not replace the first marble? So first marble of red is 6 over 10 times. Then I have 4 out of 9 remaining marbles. So I multiply those. I get 24 over 90, which simplifies down to 4 over 15.